Hello, my name is Silvana Villalba. In this video, I will explain some modifications I will propose for the osmotic dehydration experiment presented by my classmates. These modifications are focused on improving mass transfer, data accuracy, and overall process control. What was done? The experiment consisted of osmotic dehydration of fluid samples using different operating conditions. Two concentration ratios were used, 1 to 1 and 1 to 2, and two temperatures were evaluated, 20 degrees Celsius and 50 degrees Celsius. The process was carried out over a period of 60 minutes. During the experiment, several parameters were monitored, including grades bricks, temperature, and simple mass. Additionally, important variables such as wear loss, solid gain, and process efficiency were calculated to evaluate the performance of the system. I identified some important issues that affect the results. First, there were problems with agitation. Poor mixing can create concentration gradients around the fluid, reducing the efficiency of mass transfer. Second, the temperature instability was observed, especially at higher temperatures, which can affect diffusion rates and the process consistency. Finally, inconsistencies is in grade bricks measurements we report, mainly due to differences in cooling time before taking readings. These issues can significantly impact the accuracy and reproducibility of the results. The first modification I propose can be implemented using the current laboratory resource. To address the agitation problem, I would implement a standardized manual mixing protocol. This means ensuring that all samples are stirred at the same frequency and intensity throughout the experiment. This will reduce variability and improve mass transfer between the fluid and the solution. Regarding temperature instability, I would recommend more frequent monitoring and maximizing the head loss by covering the system during the experiment. Additionally, for the grace bricks measurements, I will establish a fixed cooling time before taking each reading. This ensures that the measurements are taken under the same conditions, improving consistency. These changes are simple, do not require additional equipment, and can significantly reduce experimental error. The second modification involves incorporating additional equipment to improve precision and control. I would recommend using magnetic stirrer to provide constant and uniform agitation. This eliminates the variability associated with a manual mixing. A thermostatic water bath would also be very helpful as it allows process temperature control, especially for the 50 degrees Celsius condition. This helps maintain stable operation conditions. Additionally, a digital refractometer would improve the accuracy of the degrees bricks measurements and reduce the human error. These tools will allow better monitoring of the system and more reliability data, particularly when the calculating water loss and solid gain. In conclusion, the main issues defined in the experiment were related to agitation, temperature control, and measurement inconsistencies. The proposed modification addressed these problems by improving both the methodology and the equipment used. As a result, parameters such as water loss, solid gain, and efficiency will be more accurate and reliable. This will lead to better understanding of the osmotic dehydration process under different conditions. Thank you for your attention.